Hello, everyone. Hope you're doing well. My name is Evgenii. I'm engineer at the Health Samurai, working on FHIR Box FHIR server. And validation and terminology is my main point of interest. And to be honest, that's where I spend most of my time with FHIR Box. And before moving into today's main presentation topic about FHIR Schema, let's look at where we at with validation as a whole right now. So validation is important. I guess everybody can easily agree on that. Why? Because it enforces interoperability, and interoperability is a whole thing in FHIR. And whenever your server or client tries to send some crappy data, validator prevents it. So it's as simple as that. Like, no things like this one. At the same time, how many validation engine implementations do we have? So there's a 2.5 open source ones, like in Java and C#, tons of closed source ones, which comes with the FHIR service itself. And let's be honest, they don't exactly play nice with each other. So they produce completely different error messages. Sometimes they opt out to ignore important things such as slicing or terminology bindings, and behaves completely randomly in edge cases. And here it is, the edge case. It may look synthetic, but it's still a FHIR. So we have a patient record with a given and underscore given names, and we have this pair of nulls value. Usually we use nulls in FHIR to align primitive extensions, but in this case, this is just incorrect value, which should be rejected by L1 FHIR path constraint. And let's look how actually FHIR servers behave in this way. So we have a utility in Samurai, it's called FHIR Umbrella. This is an open source tool to test out public demo servers. And here we have the same patient record with nulls, and let's try to send it. And before I press send, do you have any ideas how many servers from these 8 ones will reject that? Like, so let's look. OK, so we don't look at the reference one because it's almost impossible to set up a create function in reference implementation, but FHIR Box. OK, it complains about empty value, sort of fine, but not about L1 constraint. HAPI just happily accepted, and everything is fine. They just streamed null value. Matplum complains about nulls. Clojure, OK, they complains about L1 FHIR path constraint. Firely, they just streamed this null value. Google server, oh, they actually added some empty string and preserved these nulls. OK, that's fine. Same in Microsoft FHIR, they just silently trimmed nulls. And AWS, yeah, complains about L1. So that's actual current state of validation. And it's not a blameless thing, but we just have this state. So validation is hard, and current validation spec doesn't make it easier. It lacks a lot of details. Lots of features are underspecified, and tons of practical wisdom lives somewhere in Zulip threads. And at the same time, current validation spec is not really developer-oriented. Here's what I mean. Take a look at the FHIR path spec. So every function, every operator have all input-output specified, all possible edge cases. They even described how to handle null values, etc. And you can just read through this spec and implement FHIR path engine, I guess, in 1 week or 2. And let's be honest, it's impossible with current validation specification. So what we can do? I guess we should adopt good things from the projects like SQL on FHIR or FHIR path and implement them somehow. So one of the first things is test suite that covers all possible like input, outputs, edge cases, etc. Reference implementations, and we need a lot of them because we have different backgrounds like static typed ones, dynamic guys, and the more implementations, the better, because we just can have an influence from it. Of course, we need implementers working group dedicated to the implementers that discussing how to implement actual engine, and the test metrics from which you can deduce like which features you're actually missing. And here it is, finally, the FHIR Schema, the project that tries to solve all of these problems. So the FHIR Schema is a project designed to make validation accessible across like all of the programming languages. It's heavily inspired by JSON schema. So it's like gives you a really programmer-friendly representation of FHIR structure definition, on top of which we have a simple yet super detailed validation algorithm. And of course, we have a test suite that is similar to the SQL on FHIR, I guess, that we have JSON inputs and possible operation outcomes. And before we move on, there's like one important thing to mention. This is not a replacement for structure definitions, so it's not about authoring. And of course, this is not yet another fish. So this is for implementers, for guys who's doing validation engines. So project contains like 3 main parts. This is transpiler. This is the thing that transpiles structure defs to the FHIR schema format itself, validation algorithm, and test suite. I forgot to include it to the slides. And today we're going to focus on the format and algorithm. We just do the brief overview. So the format. Structure definition by itself is just a flat list of elements. They have path, ID, it's sorted, but your FHIR data is actually a tree. So sometimes a deeply nested trees or something. And as implementer, if you don't really care about performance or you're just doing some naive thing, you can just scan this list while you're traversing your FHIR data and perform some validation. But most of the current implementations are actually doing the same thing. They're trying to index this structure or put it in some tree-shaped something. And here's where ideas of JSON schema naturally comes in. So we can represent schema with the validation constraints as a tree that resembles these FHIR data. So as you can see, here we have FHIR schema, and it's kind of similar to the patient data. And let's take a quick look at the actual schema. It's in YAML, but actually FHIR schema defined with JSON, but YAML is for like to make it short. So what we have, elements defines possible keys in your data, so it's like obvious, okay. Arrays is a first-class citizen, so you don't need to deduce it from cardinality. So you already know that something is array or a scalar value. Terminology bindings are similar to the structure defs. It's like just binding with the value set reference. So we have polymorphic roots for the ease of use. Whenever you need to validate these union polymorphic types, you can just check allowed choices. FHIR path constraints are similar to the structure defs. As constraints, they can sit at the top level or on the element level. Nested elements as like just as regular elements. Like arrays, requiring exclusions are also a first-class thing. So you don't need to deduce anything from the cardinalities. Once again, you just have this required or excluded. And reference set limiting. So whenever you have a reference type, you can limit it by this reference set. Of course, there's lots of other things to cover, but I guess it's a good idea to discuss it during working groups. And yeah, almost forgot slicings. It's the most trickiest part of any validation engine. So the FHIR schema, in FHIR schema, they simplify it just to the match keyword. Effectively, it means that every slice just have a function which able to capture data element. There's the different types of these matchers, like you can match by terminology binding validity, by pattern, by I don't know, profile validity, etc. So there's lots of types, and it closely resembles slicing in structure defs. Okay, so that's the format, and let's discuss the validation algorithm. So before looking at the actual validation algo, I want to mention one interesting property. So the FHIR schema validation allows you to validate things in snapshotless mode, so you don't need to generate snapshots, and it opens these 3 particular features. One of them is the runtime flexibility, so You can patch out some broken FHIR path constraints in US core, for example, or you can just do this monkey patch stuff in runtime because we don't froze things with the snapshots. We can validate multiple profiles simultaneously, so you can just throw in, I don't know, US core, M code, what else, like tons of profiles, and whenever errors will be produced, you will see errors from these specific schemas and profiles. And also it allows you to perform profile discovery. So you can just like throw tons of different profiles into your data and see which of them is valid. So you can just discover applicable formats to your data. So algorithm from like this super undetailed overview. Whenever we start validating some piece of FHIR data, we need to collect initial schemas. So in this case, we have a patient record, so we know this is the patient, and we also have a reference to US core. And first of all, we obtain these two schemas, like US core patient and patient. By looking at the patient schema, we deduce that it actually have a base definition that pointing to the domain resource, and domain resource pointing to the resource, and like we collecting this schema set. So after we collected this schema set, we check in the top-level constraints, such as FHIR pass invariants that define the top level, required keys, etc. And after we did that, we start to traverse the data. And for example, let's take the name key. Having this key somewhere in state, we can traverse through the schemas we collected on the previous step. And for example, from the US core and patient, we will get human name and the US core patient human name subschemas. And after that, we check in specific node level constraints. So we check in types for the primitives, slicings, shapes, etc. And we're doing that by grouping. So once we check that something is a string, we don't need to check it like several times with all of these schemas. And if we see none a primitive terminal, we just like doing recursive descent and repeat this thing once again. So there's a like really hardcore insights after 1 year in production. So Box uses FHIR Schema engine for 1 year. We're kind of okay with that. And there's a few interesting insights. So transpilation process must be stateless. Because right now it's stateful and require you to bring in all the packages. And this is sort of reintroducing snapshotting at this transpilation level, so we can get rid of that. And schema order doesn't matter. It's like really technical details. One of them is really interesting about slicing groups. So they must be uniquely scoped because whenever you try to validate multiple profiles, slice names are not unique, and you need to introduce this slicing group level scoping. And we need a defined error specification because we already feel this mess in test that we produce different error messages, and we should unify it somehow. So what about roadmap? During this summer season, I guess, we plan to open up our test suite. We're actually using an 8-box. It's similar to the Smart on FHIR tests, as I mentioned previously. We're working on finishing the reference implementations, one of them in JavaScript and one of them in Clojure. We have version 1 of the specification. It's published, but we want to transform it into something more FHIR-like. I mean, publish IG with IG publisher and all this stuff. And we also plan to start a public working group. Yeah, so here's the artifacts you can explore. So there's a specification draft, playground where you can test out the validator. Transpiled package dump is just a mirror of packages 2 with all FHIR schemas compiled. Reference implementation in Clojure, reference implementation in JavaScript. And yeah, you can contact me on LinkedIn. I'm also available on Zulip. We have a dedicated stream for FHIR Schema in FHIR Zulip, I guess. So feel free to reach out. And yeah, that's it.
Thank you, Evgenii. Are there any questions from anyone in the room? Yeah.
So thanks for the presentation. I haven't seen it in examples, but is there something like the asserts possible in your FHIR schema?
Could you repeat it?
Like this more complex asserts that you have in an IG and some profiles, like if there is an element, if there is element A, then element B has to be like that type, because it could be multiple things.
I guess there might be situations where profiles are conflicting with each other, and but in this case, the errors that will be produced will be tied to these exact schemas that are actually producing these errors. So, for example, if schema B bringing in some conflicting type or something, this error will be pointing to that actually schema B producing it, and schema A will be fine, I guess, and it will not produce any errors. So
something like asserts is possible in FHIR schema.
Yeah.
Okay.
Yes.
Is it possible to get the transpiled FHIR R4 schema? Have you guys already generated that?
Yeah, sure. So there's this transpiled package dump. There's a mirror made by Graham and the team named packages 2. It just contains all AGs from like simplifier and all possible atom feeds. So we transpiled every AG. So we have in community right now. So you can like feel free to inspect this bucket.
What's the state of the JavaScript reference implementation? I know that was in progress.
Yeah, it's like way deep in progress, because it's kind of hard. We already have a closed source 1 implementations, and we need to force us to do this thing in free time. But yeah, feel free to reach out in Zulip or LinkedIn and just force us to finish it.
Do you expect FHIR schema to become like complete in term, like on par with the Java validator, or are there things you expect not to be implementable?
I'm not sure. Let's be honest. I'm not sure that it's possible, because there's tons of different extensions that are hidden and they're just scattered all across different tooling IGs. And I guess there's a chance that it's possible to implement like 99.99%, but there always will be some sort of extension in structure definition or an element definition that change validation semantics completely.
Okay. Yeah.
Anyone else? Okay, then I think it's time to round up and move towards lunch. Thank you, Evgenii, once again for your presentation. Reach out to Evgenii through one of his communication channels, and enjoy your lunch.